We'll start today's lesson talking about equivalent fraction. The term equivalent should be key for us here. We're still working through 8.1a, which is comparing and ordering rational numbers in various forms, as well as 8.15a, where we're going to communicate mathematical ideas using appropriate methods, tools, and models. So, as we were saying, equivalent fraction. So, what do the term equivalent mean? It means something is equal. So, let's just dive right into it and see what we come out. We want to, let's say, for instance, we want to find something, and I'm going to, if that's okay with you, I'm going to attempt to draw a circle. And we say we want to find something that's equivalent to what we want to do here. So what I'm considering is, we consider this pizza, and that's 1, 2, 3, 4. Okay, 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8. So we have a pizza, and we have exactly 1, 2, 3, 4, 5, 6, 7, 8 slices. So we have a pizza with 8 slices. That's my Excuse me, we'll get it together. We have 8 slices. So we have these 8 slices of pizza. Neat rule. Just wanted to put that up there so you can see it. What are we talking about as a fraction? So if we look at it as a fraction, we will see that we have a denominator of 8. We have 8 slices. So as a whole, we have a denominator of 8. Well, let's say, for instance, that I want to take 4 of the slices all for myself. I'm not going to pass them out to anybody. I'm going to have all 4 of these slices to myself. So that means if I were to consume 8 slices, and I will 4 slices actually, and I would see how many slices is left. 1, 2, 3, 4. As I can see, I have 4 of the 8 slices remaining. Well, let's just say, for instance, also that I have the same pizza, and then this time when I went to Papa John's, I told Papa John's, just cut it in twos. I don't want to deal with peeling them off. Just cut the pizza in twos. So if we look at this particular pizza, we see that we have 2 parts. So we have a denominator of 2. And again, I say, well, I'm going to eat half of it on my own. So I'm going to dissolve or devour or eat this whole side. Okay. So how many do I have left as shown? And I have 1 over 2. Now if we look at this one and this one up here, we see the same thing. You see this horizontal line here that's dividing the 2. Maybe I should have put it the same exactly, but you see that horizontal line, it's dividing the 2 halves. So we can easily say that just by this picture model that 4/8 is the same thing as 1/2. They're both the same thing because you still have this same amount of pizza left. Well, let's not stop here. Let's take a look at another one. Say if again I have this pizza, and then this time I decide that I wanted to. There's my half. And here, 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 here. So I have 1, 2, 3, 4, 5, 6, 7, 8. But I want it smaller because I'm going to try to accommodate more people. So I said, let's cut it smaller. Glad I don't have a piece of knife. Okay, so let's count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 16 pieces. So here we can say that our whole is 16, which our denominator would be 16. And again, I'm greedy, and I am going to eat half of it. I'm going to eat 1, 2, 3, 4, 5, 6, 7, 8. I'm eating 8 slices. So as I count, I have 8 slices remaining. So if I have 8 slices remaining, again, what I'm seeing is 1/2 of the pizza is left. So these equivalent fractions here with these examples are just simply telling me that if I were, no matter what the actual denominator is, if I were to take 2 and divide it into 8 and multiply what I get times the top number, I will go from 1/2 to 4/8, and that is multiplying by 2. Also, if I take the same 2 or take 8 and divide it into 16 and multiply the top by what my quotient is, I will again get the exact same, which is times 2. So as we look at equivalent fractions, first of all, we need to understand that they are equal and they are factors. There are factors from the denominator that correlates directly with the numerator for each particular piece. And this is what we need to know here. We need to really know how to factor and how to be able to bring a particular set of numbers down to it, to actually equivalency. So without drawing the model, let's take a look at something and see if we can actually work this out. So we have here, and I think I need to clear some space for us so we can actually work these particular problems. So, but the only thing we're doing is I showed you from a model. I remember in the math lab a student telling me that it's much easier when we work at them from a model. And the model are good, but we definitely need to establish these basic rules and concepts, because we won't be shown models most of the time in our lives. We need to understand that models are one way of proving, but they are merits a way of proving how mathematics work. So anyway, we will take a look now at some problems and work these problems accordingly. Pretty easy though, guys, pretty easy. So what we do is we have, let's see, 4/6. And they're asking us to create, well, let's just create an equivalent fraction to 4/6. Well, as I look at that, the first thing I can do is look at the factors of 4 and the factors of 6, and I have 4 times 1, 1 times 4 actually, I have 2 times 2, and for 6 I have 1 times 6 and 2 times 3. So 2 is common for both. So what I can do is I can divide both of these by 2, and it should give me an equivalency. So if I divide here, I'll get 2, and if I divide here, I'll get 3. Okay, well, that's not the only way. We can also take this same fraction and let's go ahead and do it, 4/6, and now we can multiply it again. Let's multiply it by 3. So here, if we multiply both by 3, we will get 3 times 4 is 12, and 6 times 3 is 18. What makes it equivalent is we multiplied both numerator and denominator by the actual same factor. So we're not changing the value. Here we divide by the same factor, and we're not changing the denominator. So let's take a look at another problem. There's myriads of ways that we could have done this, and myriads of fractions that would have given us and actually 2/3 would be in a simplified form. But we're just trying to show you the concept for measuring equivalence. So here we have, let's try 10 over 12. Okay, so again, we can divide, looking at the factors, 1 times 10, 2 times 5, and here we have 12. 1 times 12, 2 times 6, 3 times 4. But notice 10 only shares 2 with 12. So we can actually divide both by 2, and if we do so, we should easily get an equivalency. So here we will have 5 over 6, which in reality simplifies it to its smallest term. And we can also take, so let's take this same fraction, and here we'll have 10 over 12, and let's multiply it by 2. We won't go deep into this, just multiply it by 2. Here you'll see we get 2 times 10, which is 20, and 2 times 12, which is 24. And again, they are equivalent. They are equivalent. 10, 12, 5, 6, 20, 24 are equivalent fractions, as long as you remember that what you multiply by both or divide by both, and divide will pretty much simplify, that you are getting both denominator and numerator. If you divide by the same same number, or multiply by the same number, you're going to get an equivalence. Okay, so what I'm going to do is I'm going to leave you with this problem, and I'll let you work it out. If you have any problems with it, please address those problems in the comment section. So here we have 4 over 16. So give me 2 different fractions that is equivalent to 4 over 16, and I will see you soon.